Okay, in this video we're going to be going over the topics in Chapter 5. First thing we'll do is talk about the relational model concepts. We're going to define some terms in there and look at the characteristics of relations. Then we're going to move on and talk about constraints. Okay, and a constraint is something that limits us, and we have several different types of constraints in a database, and we'll review those. We'll look at some operations that we can do to a database and what constraints those might violate, or how they might be good operations as well. And then finally, we're going to briefly review what a transaction is within a database. All right, going to start talking now about relational model concepts. Okay, and the first thing I want to do is talk about a table. Showing a picture of a table here, I actually just cut it right. I did a select star on the employee table in the company database, and that's what we're looking at here. Okay, want to talk about some terms associated with this. Okay? As you heard, I called this a table. You may also hear it called a relation or an entity. Those are synonyms. They all three mean the same thing. I will use different terms predominantly when we're in different parts of the course. Like initially, we're going to talk about relational notation, so I'll talk about relations. When we start drawing our entity relationship diagrams, I'll talk about entities there. And as we move on to relational algebra and SQL, I'll talk about tables. It is possible I may use those terms throughout the course, though, interchangeably. And if I do, just remember that they are synonyms for each other. They all mean the same thing, a table. Okay? Now, these columns, we may hear these, I just said column. Could also be called an attribute. And that's the word that I use most often. I use column a bit. It could also be called a field. And that's a term I'll use rarely, if ever. It comes back when we did file processing as opposed to using databases. It's a kind of a legacy term. Okay? Now for the rows in a table, we can call them a row. A term, so I'll use row a little bit. I could also use the term tuple. Okay? And I use that quite a bit. And all a tuple is a row in a table. Another term you may see in the text, and I doubt if I'll use it very much at all, is record. Okay? And a record is the same thing, but again, that's a holdover term from the days when we did file processing as opposed to use databases. Okay? So those are some terms to understand and to be familiar with. So when I'm speaking about things, if I talk about a relation or a table or an entity, you understand it's what we're looking at now. When I talk about an attribute, that's one part of a tuple or a row. Okay, so that's what we're looking at here. Those are the names that I'd like you all to understand. Now, the next term that I want you to understand is domain. Okay, and each attribute has a domain. Okay, last names. The domain for last names are last names. Okay, that's all we should put in there is a last name. Shouldn't put a social security number in there, a birth date, an address, the salary. The last name should be dedicated to just last names. Likewise, in the social security column, that should be a valid social security number, right? 9 digits long, and I'm sure the Social Security Administration has a few rules about it, but it's a 9-digit number. Okay? Birth dates. Well, if that's a birth date of an employee, we probably aren't going to have somebody that was born in 1776. Doubt we got anybody alive like that. So it needs to be a birth date that would be reasonable to the employees we have employed at our company. Okay? And that's what a domain is. It's the range of values that we can pick from to assign a value to an attribute in a tuple. Now, the next thing I want to talk about is how we would actually write the relation in relational notation. Okay, so I'm going to erase this, what I just wrote down here real quick. Oh, I'm not hitting the delete key. shoot. Okay. So there's two types of ways that we write the relational notation. One is for the schema, okay, and the other is for the instance. And the instance is what's currently in the table at this time. Okay? So I am showing an instance of the employee table right now. If I would add another employee or delete an employee or change an employee's information, I would have a new instance of the table. Okay? So let's see how we would write this in the relational notation. Okay? For the schema, it needs to be written in all caps. Okay? So it would be employee, if I can spell, employee, and then we would have F name, comma, name, B date, address, sex, salary, and Dino. I didn't copy Dino up here, but this actually says Dino. Okay. So there's the how it, well, no, because I didn't make it all caps. Let me do this. Thank goodness Word does that for me. I will make that all uppercase. Okay. So there's the start of the relational notation. We're not indicating what we call primary keys or foreign keys yet, but we'll get to them later on. All right. For right now, there's the schema. To write it for the instance, I would simply do that. And then I would make it all lowercase. And every single letter needs to be lowercase. If you're typing this in Word and it automatically capitalizes that first letter for you and you don't change it, you'll lose a point. Okay? So everything needs to be lowercase. Right? And again, we still haven't looked at the foreign keys and primary keys, but we will get to that shortly. Okay. So that's a little bit about the naming there. Right? Now for some characteristics of the relations. All right. There's a few things. One, order. The order of the tuples in a table does not make a difference. So, for say, if Alicia's record was at the top and John's was at the bottom, that doesn't matter. I mean, they are still the same people. They still have the same information, so it just doesn't matter. Okay? The order of the tuples, right? Usually they're put in by what was inserted first. Okay? And if you're uploading millions of records, you really don't care which was inserted first as long as all the data gets there. Okay? So the order of the tuples has no meaning at all. Okay? Likewise, the order of the attributes has no meaning. Okay? Social security number could be first, it could be last, it could be anywhere in here. Same thing for address. It could be the first attribute. It doesn't matter the order that they're in. Right? Some database folks like to keep the primary key, or if it's a composite attribute or a composite key, the attributes that make up the primary key as the first attributes in a table. Okay, some folks like to do that. Doesn't mean that you have to do that. So the ordering of neither the tuples or the attributes within a table makes a difference. Okay? That's just part of what being a relation is. It doesn't matter. Now, a couple other things, and actually this table actually violates one of them. You can't have multi-valued attributes. Okay? A multi-valued attribute is when you would basically have an array, right, within one of these fields, or you might name something like, if all the dependents were in here, you could have dependent 1, dependent 2, dependent 3. Okay? That also would be considered a multi-valued attribute. We don't want those. The reason being is they make processing a lot more expensive. It takes more CPU resources to do that. Okay? So we want to design our database so we don't have these multi-valued attributes. Okay? Things that you could consider an array. Likewise, we don't want what they call composite attributes. With an array, you have attributes. They come from the same domain. Okay? That's what the value would be. For a composite attribute, you have data that is not similar. If we look at our address, this actually breaks the definition of a relation because it is a composite attribute. We have the street address, we have a city, we have a state. Okay? In reality, this should be broken out into 3 different attributes. Have a street address, a Houston, and a Texas. Or a state, sorry. Street address, city, and state. Okay? That's how it should be laid out. Unfortunately, the author didn't do that. So we do have a composite attribute there, which you really should never have. And think about that. If we had an attribute that just said city, it wouldn't be real hard to sort by that and find all the folks in Houston. It'd be a pretty simple task to do. If we wanted to find Houston now, all of our employees that live in Houston, we're going to have to parse a string. We're going to have to use substring functions and things like that to get in there, find the first comma, the space after it, up until the second comma, and then pull out those characters in between. That's a lot more expensive in terms of processing. For one, I'm going to have to go through the whole table. And if we've got 1 million employees, or that's kind of unrealistic, but 10,000 employees, I've got to read every single record. Where if I had this in sorted order by the city, it was in a different attribute, all I have to do is start at the first one of Houston and then go until the city changes. A lot quicker to process data if it's not in these composite attributes. And then the last thing I want to talk about is the problem that we have with nulls. All right. If you have a null, okay, it could mean one of 3 things. Okay. A value exists but is unknown. A value exists but we just don't have the data in front of us right now. We know that the value exists. Or an attribute just plain old doesn't apply. Okay. So we don't want to see nulls in our data, right? Because we just don't know what it really means. We want as few attributes to be null as possible. I want to show you a couple examples here. If we just go look here in the schema, okay, notice that James does not have a supervisor's social security number. That's what the super SSN attribute is. It's the social security number of that person's supervisor. So John has that person as the supervisor, which is Franklin. Jennifer is this has 888-6655, which is James. But Jennifer, her social security number is 9876, and she's got somebody working for her, a couple people working for her. Okay? But if we look at James, it's null. And that means that James is the president of the company or the top level of the organization chart. He doesn't have a supervisor. So with this, if that's the only null attribute in the whole table, I get that. I can make sense of that. It makes sense to me anyway that the president of the company does not have a supervisor. However, if we look down on the works on table, this is for James as well, but he has charged null hours to a project, to this project 20, which is the reorganization project. Okay, I don't know what that means. Does that mean the value exists but we don't know it right now? Value exists but it's unavailable, or it just plain doesn't apply? And I don't think it would be it doesn't apply, because if you work on a project, you need to charge hours to it. That's kind of how it works out there when you're doing project management. You track the hours charged to your project. And to have somebody that's assigned to the project but doesn't do anything, that doesn't make a lot of sense in my mind in terms of project management. Okay, so we want to avoid nulls. All right. I could show you something else here. If we look, this is the orders table, and we'll be using this My Guitar Shop. Now for the orders, it kind of makes sense for the ship date column to have some nulls in it. If the order has processed but it hasn't shipped, okay, that makes sense to me. Eventually when the order ships, we'll put a value in there and we'll be good to go. Okay, so this is another case where it makes sense, right? Because eventually, once all the orders have shipped, we'll have no nulls there. We may have new orders coming in and they haven't shipped yet, but those nulls will get taken care of over time. So that's another place where they can make sense, right? But what you want to avoid is where nulls are there permanently and you have a lot of them scattered throughout your data. If you do, you probably need to design your tables a little bit better. Okay. Okay. We're now going to start talking about constraints that we can impose on the database through our data definition language, or those commands that create our tables. Okay? Before we start talking about the constraints, though, there's a few terms that I want to describe for you, or define for you. Get some descriptions out here. Okay, the first term is a primary key. Okay? Now, primary keys, the purpose of them are to identify a row in a table. That's their job. Okay? So I'm going to look at the company database schema handout here. Every attribute that you see underlined is either the primary key or part of the primary key. Okay? We do have 3 tables that have 2 attributes underlined, and those are called a composite key, and we'll get to that in a second. Okay? But they are a primary key. If I have the Social Security number, I can use that Social Security number to determine an employee's name, their birth date, address, salary, who their supervisor is, what department they work in. So that Social Security number is a primary key. It identifies a row. Okay? So that's the purpose of a primary key. Okay? Now there's 2 characteristics of a primary key, or I think, and the 2 characteristics are that primary key needs to be unique. Okay? So looking back at our Social Security example, wouldn't really work if we had 2 employees with the same Social Security number. We wouldn't be able to identify a row in this table. So they need to be unique. And that's a fairly easy concept to grasp there, I think. Okay? Department numbers need to be unique. If we had the same departments with the same department number, that wouldn't be a valid primary key. We couldn't look up the department, find the name and the manager. Okay? Another characteristic is they need to be either, you can call it irreducible or minimal. Now, what does this mean? It means that it needs to be the smallest number of attributes possible to identify a row in that table. That's what we're looking for. Okay? The smallest or the minimal number of attributes necessary to identify a row in the table. So let's come back over here and look at the company. Say I determined that I need to have first name, last name, and Social Security number to be my primary key. Okay? That wouldn't be a valid key. The reason is we don't need the first name, we don't need the last name. All we need to identify a row in that table, the only thing we need is that Social Security number. So that's what it means by reducible. Okay? You have to take away any unnecessary attributes so you're left with the minimal number of attributes necessary to identify a row in a table. Okay. If we look at works on, this has got 2 attributes for the primary key, but we couldn't take either one of those away from being the part of the primary key. Because one, we can see that if we did, we wouldn't have the unique quality, right? And if I want to see what employee charged to which project a certain number of hours, I need both the Social Security number from the employee and the project number to be able to determine how many hours that employee charged. Okay? So in this case, we have 2 attributes to make up the primary key. Okay? And so based on what we've just said, we've given the definition for a couple more terms. One of them is the superkey. Okay? A superkey, I think the book uses it 1, but I'll put a space in there. A superkey includes the primary key. Okay? Needs to include it. The default superkey is all attributes in a table. Okay, so based on that, we can say that a primary key is a super key, okay, because it includes the primary key. But not all super keys are primary keys. And if we come back over to our company database, looking here at the employee table, okay, the default super key is every single attribute in this table. That's obviously reducible based on what we just said. We can reduce that down to the SSN. So not all super keys are a primary key. They include the primary key, but they don't meet the definition of a primary key. But a primary key, well, it includes the primary key. It is a super key as well. Another term that we talked around a bit is something called a composite key. And all a composite key is it's a PK made up of two or more attributes. Attributes, if I can spell there. Okay, two or more attributes. So if we come back to our company database, okay, the employee does not have a composite primary key. Department does not. Department locations does. We've got D number and D location that make up the primary key. There's a composite key. WorksOn has a composite key. It's made up of ESSN and PNO. Okay. Project only has a single attribute primary key, so it's not composite. And Dependent has a composite primary key made up of two attributes. Now, one thing I want to make clear here is a table only has a single primary key. Doesn't matter if it's a composite key or not, it's only a single primary key. So no table has primary keys, right? Even if it's a composite key, it's still only a single key, right? And I want to show you some of the SQL that we use to create these primary keys. And this might help you understand a bit more. Okay? Here's the SQL to create that employee table. There's the constraint that we use to create the primary key. It only has a single attribute in there. Okay? If I look at the dependent table, though, its constraint clause for building up the primary key, it includes the SSN and the department name. It does not have two constraint clauses, one for each, one for SSN and dependent name. There we'd get an error if we tried that because we'd be trying to define two primary keys, and we can only have one. Right? Now we can have multiple. If I get down here to the WorksOn table, I know that it has two foreign keys. They're two separate foreign keys. Got the employee social security number referring to the employee table primary key, and we have the PNO in WorksOn referring to the project table P number. Those are separate foreign keys. You can have not as many as you want. I'm not sure if there's an upper limit. I'm sure there is. But you can have quite a few foreign keys in a relation. And there are different attributes referring to different primary keys, and that's just fine. But for a primary key, it's only a single one. Okay. Now, when we are looking at data, and in a couple of weeks you'll be doing this, we're going to be taking a form. Let me spell that right. We'll be taking a form and creating some tables from it. Okay. When we do that, when we take a business form and we look at it, we may decide that we come up with, for any given table, as we're doing our analysis of that data, that we have more than one attribute that's a good primary key. Okay. So what do we do in that part? Okay. Well, all those attributes that could be a primary key, we call them candidate keys. Okay. So let's say I'm working somewhere like CWU. They have my social security number, and they also have my employee ID number, or my faculty ID. Okay? Either one of them could be the primary key for the record they keep on me, just the base record. Okay? It shows my name, my address, my rank, salary, whatever else they keep. I'm not sure. Okay? But those are both good candidate keys. My social security number, hopefully I'm the only one using that. Likewise with my employee ID number. Okay? Now, if we have these candidate keys, we need to pick one. One to be the primary key. Right? So let's say I pick employee ID. Okay, so that's going to be the primary key in the employee table that I'm creating. Okay? And this has nothing to do with that company database schema. This is just hypothetical right now. We're talking about what record would be kept on me at CWU. Right? And I don't know everything they have in there. I'm just using this as a hypothetical example. Okay? But I picked one. Okay? So that's now the primary key. Our social security number, though, the other gosh, I can't spell today. Attributes might be more than one. They are called alternate keys. In this case, SSN, that's called an alternate key. Okay? So any candidate keys that you have, you got to pick one to be the primary key. The ones you did not pick, in this case we only had social security number, that is called an alternate key. Why do we even want to keep track of that? Well, it's possible we may need to reference a record in the table based on an alternate key, and the database administrators could create indexes based on the alternate keys to speed up that access. Okay? So when we're looking at data from the very beginning, we're looking at just a form and we're pulling all the what we think will be attributes off that and divided it into themes that will turn into tables. We start looking at that data and we start coming up with those candidate keys, possibly. Okay? This case, the data we were looking at had both social security number and employee ID. I picked employee ID to be the primary key for that table. Social security number is still going to be in it, but now it's called an alternate key. And then sometimes when you're looking at data, you just aren't going to have a good candidate to be a key. Just not happening. All right. So what do we do in that case? Okay. So if there's the data we're looking at has no inherent attribute that satisfies the rules or the constraints for a primary key, I guess we could say. Okay. All right. What do we do then? Okay. We do something that's called a surrogate key. Okay. We create a surrogate key. And what does this mean? It means that our data will create, because we got to have a unique identifier for every table. If we look at the data and we really don't have anything, say it's for a customer, okay? Well, a customer names, they can change. Customer phone numbers can change. Customer emails can change. Customer addresses can change. So, or the names may change, like last name. If someone gets married and changes their last name, okay, that can change. But also, any name is not a great candidate for a primary key because they're duplicated. Okay? Your address. We could have more than one customer living at the same address. You know, you can change the phone number, right? Because I know phone numbers, when I worked at a financial services firm, the phone they gave me, some person had had that phone before, and for about a year and a half, I got calls from bill collectors for that person. Okay? That phone number no longer uniquely identified whoever that person was. It now identified me. But I gave that phone up when I left that firm. So now somebody else probably has that number. So phone numbers aren't a great one either. All right? So in that case, what do? We create a surrogate key. A surrogate key is usually numeric, and the database will keep track of incrementing it so we don't have any duplicates. So it follows that, satisfies that uniqueness constraint. Okay? In a database, if an attribute is going to be a surrogate key, this little column here, I know if you're on a small screen, but it says AI. Down here it says auto increment. We will check that box, make it an auto increment field, and then we don't insert data in there. In our insert statements, we can either not even leave it if we're naming the columns when they do the insert, or if we're just using all values, then we just put the keyword default. And we would let for that attribute position in our insert statement, and we would let the DBMS go ahead and assign the correct number there. And that's what we do with a surrogate key when there's just no inherent data that meets the constraints that we have on what it takes to be a primary key. Okay, there's one more term I want to define, and it's called a foreign key. And this is actually not a key. It doesn't identify a row in the table that it's in. In fact, a foreign key can, the same value can be duplicated multiple times. Okay? But what does a foreign key do? It references or refers to a primary key. And this is how the relationships are built between tables. A foreign key references a primary key. Right? Now, you'll read in the book, you'll see on Wikipedia and other places that will say references a primary key and references an attribute in another table. That does not hold true all of the time. I can show you that right now because as you can see on back here, on this diagram, the foreign keys start at an attribute where the arrow starts, and they finish pointing to a primary key. Okay, so in our case here, we have a foreign key super SSN that refers to SSN. It's in the same table. Okay, this is called a recursive relationship. It is not between tables. If we come up here and look at the data, if we want to find somebody's supervisor, like John's supervisor, is this social security number? That happens to be Franklin. Okay, so a foreign key does not need to be in a different table. It just references a primary key. And this is how a foreign key referring to a primary key, that's how we create relationships. Relationships are created that way. Normally it is between two different tables. However, it doesn't hold true. Probably 98, 90%, 99% of the time it'll be between different tables. But we can have a foreign key that references the primary key in the same table. Okay? But that's how we relate data. If you remember the definition for a database, a collection of self-describing related data, this is how we solve that related part. So that's a bit of the definitions. Now I want to look at see how we would write our relational notation. Let's update that a little bit. Okay? So for the employee table, I'm going to just employee. We have F name. Oh, and got to watch that capitalization there. Okay, then we have middle init, I believe, L name, SSN. What's next then? We've got birth date, address, sex, salary, super SSN. I'll probably have to come back to that. So we got birth date, B date. Well, let's make it so I can see it. Okay, what do we have here? We got birth date, address, sex, salary, super SSN, Dino. Okay. So that's what we learned so far. That would be for the instance of the current database. Okay. Now, for primary keys in our relational notation, we are going to underline them. Okay, we underline our primary keys. Now we okay, so that, let's see if I can draw here. That's a PK. All right. For foreign keys, we've got two in this table, and we don't underline them, we italicize them. That signifies that some data is a foreign key. So we now have two foreign keys in this table. Okay, we've got super SSN, it refers to SSN, and we have Dino, and that refers over to department D number. We can see that back here on our schema. If we look on that second page, you can see we have super SSN. Remember, the arrow starts at the foreign key, referring to SSN. We have Dino, referring to D number in department, to that primary key. Okay, so that's how we write it. Let's try the, and again, if this was if it was the schema, all I would do is uppercase everything. The primary keys, I moved it a little bit with it getting capitalized, but a little bit more there. There. So our SSN is still underlined, our foreign keys are still italicized. So the schema, again, is all uppercase, the instance is lowercase. Now, let's take a look at this works on table, how we would write that. Okay? Because we have ESSN PNO, that's the primary key, but each of those in their own right is a foreign key. We have ESS referring to the Social Security number for the employee, and we've got PNO referring to P number in the project table. Right, so let's see what we do there. So we have works on, it's got get rid of that capitalization, ESSN, PNO, hours. Those are the attributes there. Okay. ESSN is part of the primary key, as is PNO. And let me turn off the proofing in this. Proofing. We're going to hide the spelling and grammar errors so you don't see those squigglies. Okay. So I just made each of those the primary key. ESSN's part of it, PNO's part of it, but they both make up the primary key. They are both foreign keys, so if an attribute is both a primary key and a foreign key, you italicize it and underline it. Okay, that's simple. And that would be for the current instance of the works on table. That's how we would write the relational notation. And we've updated it with how we indicate which attribute or attributes are the primary key and what attributes are foreign keys. Okay, so that's a little update to the relational notation there. Okay, now it's time to start talking about constraints. What is a constraint? Right. If we would go look, let's see if we can do a quick Google here and see what the definition of constraint means, just in general. So if I look up what a constraint is, okay, this is the one we're looking at. Okay, we're not going to threat or use force, but it's the state of being restricted or confined within prescribed bounds. That's what we mean when we're talking about constraints. Right? So when we're talking about constraints, it's restrictions, the data that we can put in a database. That's all it is. It's restrictions on the data. Now, why do we keep these restrictions here? Well, we want to keep a database in a valid state. If the constraints are violated, our database will no longer be in a valid state, and you don't want your database to be there. Okay? You want to have it in a valid state. So let's talk about some of the types of constraints we have. Okay? We have some constraints that go against the attributes themselves. Okay? Just any attribute. Okay? We can, well, there is a domain constraint. This can't be fully implemented with SQL, just partially. And what I mean by that is, if we look here, all we can do is specify a data type and possibly a length. Okay? That's all we can do. So we can have dates, chars, varchars, decimals. Again, if we pop open one of those, you can see there are just a whole bunch of different data types we can have there. So we can do that, right? But we really can't put a lot more restriction on that, like restrictions on valid phone numbers. All right, I don't know all the area codes in America, but I don't think it's from 000 to 999. All right, so there's some area codes that just plain old aren't valid. Okay, but that isn't something we'd normally that type of constraint in our database. That would be more implemented at the application level. Because remember, PHP, Python, Java, C++, they're going to be using SQL statements to get data back to them so they can do their work. Okay? So a domain constraint. You know, but not null constraints. We can tell MySQL that we don't want an attribute to ever be null. And how do we do that? Well, when we create our statements, we can do this. We can put not null there, right? So we gave it a name, we told it how big it was and the data type, and then we put a not null constraint right on that attribute. So that means pname can never, ever, ever be null. Right? Okay, and that kind of makes sense. We want everything to have a project number or a project name. Okay? So that's the not null constraint, and that you should probably use on most of your attributes because we don't want those nulls. Okay. Key constraints. Okay, these are another type of constraint, and the two type of key constraints we have are uniqueness and entity integrity. The uniqueness constraint means that you can't have two tuples in a table that have the same primary key. Right? Well, and that's kind of meets our definition too for a primary key. It has to be unique, but it is enforced in the database. If we were trying to do an insert statement and duplicate a primary key, it won't work. It'll give us an error. All right? So a similar constraint is the entity integrity constraint. And this means that the primary key or one of the attributes that make up the primary key cannot be null. Right? So the data has to be unique if it's going to be a key, and it can't be null. Okay? So those are a couple key constraints. If you tried to insert a record with with null for the key, it won't let you do it. Okay? And that makes sense. How are you going to look up if you have a bunch of records that the primary key is null? Well, they're not unique anymore, and you don't even know how to look them up because it's null. Right? You need to have a value in there. And then the final constraint we have is the referential integrity constraint. Okay? And the referential integrity constraint, it means that if you have a row that has a foreign key, it must point to an existing primary key. Let's look at the company database. Okay? Say down here, I would not have somebody's social security number and their dependent name in this dependent table unless there was a related employee. Okay? And the social security number was up here in the employee table. Because we can see on this back page of this handout that from the dependent table, the ESSN, the employee social security number, refers to the social security number up here in the employee table. Right? So it means that it must exist. And if we were back here, why would we even keep track of somebody's kid unless they worked here? That just gets kind of creepy, that one. All right? But we don't want to keep track of information. We can't have a row with a foreign key referring to a non-existent primary key. Right? And that's really what we're looking at. And MySQL, if you try to do that, it will give you an error. You'll say, and I think they call it a foreign key constraint in MySQL, but it's really the theoretical definition is the referential integrity constraint. Okay. So those are the type of constraints that we have on our in our database. We have these constraints that go against any attribute. We have constraints against the primary key attribute or attributes, or it's really against the primary key. And then we have referential integrity that involves both the foreign key and the primary key. That foreign key must point to an existing primary key, regardless of what table it's in, how it refers to. I mean, similarly, if we looked here and we looked at the employee table, we wouldn't put a supervisor's social security number out here unless that supervisor worked for us. So that pretty much ends up this section. Okay? We looked at quite a few definitions. Okay? We defined lots of different types of keys. Okay? We looked at what a primary key is. Okay? Its purpose, identify a row. Its characteristics, it's unique and irreducible. Okay? We defined what a super key is. Okay? And a PK is a super key, but not all super keys are a PK. what a composite key is. All it is a primary key made up of two or more attributes. We talked a little bit about how when you're looking at data trying to make sense out of it and put it in tables, you might have candidate keys for one of those tables. You pick one. It's now the primary key. The others are alternate keys. And then when we have data that we're trying to make a table and we don't have any attributes that meet the constraints of a primary key, we use a surrogate key. Okay? And all of those are dealing with the primary key. Okay? Then we have a foreign key, and it references a primary key, and that's how we create our relationships. We looked how to write that in relational notation, and then we just talked about constraints as well. Okay, so that wraps up this section. Okay, we're gonna talk about now how we can update our database, and when we're doing that, what sort of constraints we got to watch out for so we make sure we're not violating them. Okay, the three types of operations we're going to look at are insert first, then delete, and then update. Okay, so we're not going to worry about selecting anything when we get to Chapter 8 and after the midterm. Then we'll be looking about how we can do our retrievals. But for right now, and retrievals won't break the constraints, but we want to look at these insert, delete, and update operations to make sure that we don't violate any constraints. And what I'll do is, for this, I'm going to talk about each one separately, the current constraints that could be violated. Then I'm going to show you a statement. Okay? It's not true SQL, it's kind of like a pseudocode. I'll show you the statement, and then I'd request that you hit pause. Try to figure out what constraint's being violated, and then start the video again, and then I will give the answer. Right? But test your knowledge a little bit. Look at the data. We're going to be using the company database, so you'll need the company database handout in front of you. Right? So have that available, and then when you look at the operations, use this data to see if we're going to violate any constraints and what those constraints would be if they were violated. Okay. So our first one we're going to look at, okay, it's the insert operation. And when we insert, we just basically add a tuple to the table. We add another row. Okay? Now, when we do that, we have to worry about, so if we're inserting a new row, we have to make sure that we don't violate the domain constraint of the attributes. Okay? Because we can't put a birth date in the last name field, for instance. Okay? So we've got to make sure the data, we don't violate any domain constraints. It goes in with the same data type and doesn't violate the length of whatever that attribute is defined as. Key constraints can be violated. Right? We could have a uniqueness constraint violated. If I tried to insert somebody that has the same social security number as James, that's a problem. Okay? The entity integrity could also be violated because we could try to insert a record that doesn't have a primary key, or part of it would be null. And then referential integrity could be violated. We could insert a row that refers to a primary key that doesn't exist. Okay? So we've got several different types of constraints could be violated here. So, okay, so now I'm going to give you a few insert statements. Right? So if we did this insert operation, okay, we insert this. Now, inside these brackets, that's the actual, or the less than greater than, that's the actual data that's going to be inserted. And then we have, in order that it is in your handout there, first name, middle initial, last name, all the way down to the department number. That's all that data in order. Okay. So for this operation, what, if any, constraint would be violated? So I'd ask you to hit pause now. Right, think about it a bit, and then I'll give you the answer. Okay. For this, ooh, that's way over there, isn't it? We would be violating the entity integrity constraint because we can't put a null in for the primary key. That would be a social security number of null. Okay? So for this insert statement, it would not work. The DBMS would give us an error if we tried to do this. Okay? Let's look at another one then. Okay? So what would happen if I attempted this? Okay. What would happen there? So hit pause, think about it. Okay. This insert won't work either. Okay. The reason being right there, okay, it violates that uniqueness constraint. Okay. We can't, this social security number is in use, I think it's by Alicia right now, so we can't insert her twice. So we got Alicia. We're trying to insert Alicia twice. We can't do that because the record already exists. Now we could update Alicia, but we can't insert another record for Alicia because it already exists. All right, let's try another one here. What would happen with this insert statement? Okay. This one's fine. This is a good one. No constraints will be violated, so this is a good insert. As you go through, you can see everything, good social security number, nobody else is using it. It's really what we need, all the data except for the super SSN, and that can be null, so there's no data that doesn't fit the domain or it violates the not null constraint, so it's a good insert. Okay, let's look at one more insert here. Let's see what this one does. If we can do this or not. Okay. So let's go ahead and take a look at this. We're inserting Cecilia, another record for her, so hit pause and see what you think. Okay, this one is going to violate the referential integrity constraint. We have no department number 7. We look here, I believe it's 1, 4, and 5. So when we try to insert an employee record going in department number 7, not going to work. Okay, so that's looking at a few insert statements. Okay, and again, hopefully you hit pause, thought about it, and then saw what the answer was. Now let's go on to our delete statement. Okay. Now a delete statement, the only constraint it can violate is the referential integrity constraint. We're not changing data, we're not inserting data, so we can't violate any of those others. The only thing we could do is delete a record that has a primary key that some foreign key is referring to. Okay. So here's some examples. Let's take a look at this. What would happen if we did this? So we want to delete that tuple. Okay. So hit pause and think about this, please. Is it going to violate a referential integrity constraint? Okay. Well, the answer to this is it's fine. Okay, this deletion is acceptable. Right? It has no other attributes referring to its primary key. And if we look on the back side of this, we can see that here. Works on has ESSP node, that's the entire primary key. We have no arrows pointing here. So now these are foreign keys, and we can delete a record with foreign keys all day long. Now, business rules may say that's a bad thing, but that's something to be implemented at the application level, not the DBMS. Here, we're just looking here. We have no set of attributes referring to this, so we can delete a record and works on, and it's no trouble at all. No problem at all. Oh, wrong folder. There we go. So let's look at another one here. Let's see if we did this. What would be the problem? Okay. So we want to delete that employee with the Social Security number 999-88777. Okay, so hit pause and think about this. Okay. This won't work. Okay, it's not acceptable because we're going to violate referential integrity constraints. Now here you actually have to look at the data. You can't assume just because there's a foreign key relationship to a primary key relationship that every time you delete a record that it's going to violate that. If there's no foreign keys in a table referring to it, then it's not a problem. In our case, the only tuple or the only foreign key, the only attribute that points to the 999-8877 is in the works on table. And if we look here, we have, there you can see the 999-888-777, that Social Security number. That is Alicia's. Okay, Alicia's not a supervisor. Okay, Alicia's not a manager. Alicia did work on some projects, but Alicia doesn't have any dependents. Okay, so we couldn't delete Alicia because she has some records over in the works on table. Okay, so we can't do that. That would bust referential integrity. Okay, let's look at another delete operation then. Okay, let's look at this. And if I'm asked you a question like this on an assignment or exam, you would need to tell me the table with the foreign key and its associated table with the primary key. What's causing the violation? Right? Because a referential integrity violation is based on a foreign key to primary key. If a foreign key is referring to a not, or would be referring to a non-existent primary key, that's what you need to tell me. Okay, so hit pause and think about this one. Okay, this won't work either. Right? The reason being that Social Security number is in the employee table, okay? And I believe it's supervisor. It's in the, he's a department manager. I think it's Franklin's Social Security number. It's in the works on table, so Franklin's charged some hours, and Franklin has some kids. So let's go see this in our table. We've got, yep, Franklin's a 333-44555. We can see his Social Security numbers in the department table there. He's a manager. He also supervises a few people, 3 people. Okay. Coming down, we can see that 334455. He's got, looks like 4 records there, it looks like, in the works on table. Plus, Franklin has 3 dependents. Right? So each of those relationships you would need to list. You would need to list the employee super SSN to the employee SSN, the department manager SSN to the employee SSN. In fact, it's just these 4 different relationships that are shown here. All 4 of them would have been broken with that delete statement. Okay, now we're going to look at what updates might do to our database. And these operations can violate all of the constraints that an insert could, because we can change keys, we could change attributes so they don't fit the domain. Everything that we could have done with insert statement, all those constraints we could violate, also could be violated now with an update. So let's take a look at these one by one. Let's say that we wanted to do this operation. Okay. We want to update the salary of that employee to $28,000. So go ahead and hit pause and think about this. Okay. So this operation we could do no problem. Really, any attribute that's not a foreign key or primary key, you can pretty much change them to what you want, as long as you don't break the not null constraint. You know, if this salary has to be not null, you couldn't put a null in there. and that it fits the data type and length associated with that attribute. So in this case, putting 28,000 into the salary that we have, we can do that no problem. That would be a good salary. Okay, so that operation's fine. Let's try another one here. Okay, what if we did this operation? Okay, what if we did that? Go ahead and pause and think about that. Okay, in this case, we can't do it, right? It just won't work. Why? Because we're going to have a referential integrity violation. The referential integrity violation we'll have is similar to what we saw up in an insert statement. There's no department number 7. We only have 1, 4, and 5. Okay. So let's go ahead and see if we can have another statement here and see what that does. Let's go ahead and try this one. Another update here. Okay. So we want to do this. Normally not a good idea to change a primary key. Okay. And in this case, it introduces a host of problems. Okay. Well, to begin with, we're going to violate a primary key constraint, the uniqueness constraint, because somebody already has that Social Security number. Okay. But then we would also violate quite a few referential integrity constraints. Why? Because we have other foreign keys pointing to that Social Security number. So if we changed it to this one, all the foreign keys that pointed to it, the 999-887777, they don't point to a primary key anymore. Okay? So this is a problematic update as well. Okay? Let's look at one more and see what you think about it. Let's try this operation. Okay, so we'll go ahead and pause, think about it. Okay, in this case, it would be valid from the database's point of view. Okay, because we defined Social Security number to be 9 digits. Okay, we inserted 1. Okay, it's not, I don't know if that's really a valid Social Security number or not, but it meets the requirements for the database, so we wouldn't catch it. Now, if this isn't a valid Social Security number, your application program is going to have to come into play here, okay? Because from our point of view as a database, it would be just fine. Okay, last thing we're going to talk about in this chapter is the concept of a transaction. Okay. A transaction. And with a transaction, you can group together multiple statements. You can do some reading, some deleting, some inserting, some updating, whatever it is. But when you start the transaction, usually we'll put a lock on the database or the database tables we're working on. We'll lock them. We will do our transactions and then commit to work and unlock those tables that we locked. Okay? So why do we do this? Right? I like to use the example of we have 2 spouses. Now this would have to be really coordinated to make it happen, but hypothetical example, we've got spouse A over here. They're going to both withdraw $400 from their bank account. We've got spouse B over here. Okay? So say they're at different ATMs across town and they go to do the same thing almost at the same time. Okay? So spouse A, they want to do a withdrawal. Well, to do a withdrawal, the system's going to first have to check the balance. So say they started with a $500 balance. That's what's in their account. So the first thing that will happen is check the balance. Okay? To make sure there's going to be enough money when we ask for money. Okay? Next thing we'll do is they'll withdraw $400. Okay, that's fine. That seems reasonable. Now, if spouse A was just a little bitty fraction a second above them, they could check the balance, right? Because when spouse A checked, they got $500. That's how much was in the account. Now, if spouse B did their check in between these two transactions, so they checked the balance, they also got $500 as the balance. So when they want to withdraw $400, they could do it as well because the balance, hey, it's over $400. All right, so they end up pulling $800 when they update the balance here. 500 minus 400, that's going to leave $100 in their account. But they withdrew $800 when there was only $500 to begin with. So from that couple's point of view, yee-haw, they got some money. From the bank's point of view, that'd be unacceptable. Right? So how do we fix this? Okay. The way we fix it is, let me just erase a little bit of that if I can find the eraser on here. Right there. I just want to erase that line. Okay. So how do we fix it? Okay. What we do is we will put a lock here. And while that lock's happen, we're blocked over here. We can't check a balance until this transaction is finished. So we're starting our transaction here. We go check the balance, we make our withdrawal, and we update the account value. Now it's going to be 100. Okay? And here we do our unlock. So when we're all said and done, our account balance is going to be $100. After this lock is released, and that's only after, then spouse B can make their transaction. So when they check the balance this time, instead of 500, it's only going to be 100. And they won't be able to withdraw that $400. Okay? And when they find out they can't, they'll release the lock as well, because they put a lock on it before they checked the balance. They saw they couldn't withdraw $400, so we end that lock. Right? And these transactions, it's an atomic set of transactions. They either have to all happen or none of them happen. Right? And this is a fairly trivial example, but I hope you can see from this race condition why we have to have these transactions, the concept of transactions in our databases. And that finishes up this chapter.